Hello, students. I'm taking this time to prepare a short revision about supervised learning algorithms, and where we are going to focus on both regression and classification problems. But before we start, let's understand what is a supervised learning. Supervised learning is one of the type of machine learning where we start about the problem, and the problem has the independent variables which are taken as the input features, and also we have a target variable which is taken as an output or it's a label. And from the input features or independent features, also they are called the predictors, which means that they are the variables or the features that are taken like a food of our model. The food that, let's consider it in normal life, it's like a food. A food, it's a what you eat, and finally you get the output of eating. As we know, it's to be alive, right? um and in a much context of machine learning, we have first of all inputs and we have the output. Once we have both at the same time, at that time we say that we are dealing with the supervised learning. And according to definition we have in this code base, supervised learning is a type of machine learning where a model is trained on labeled data. Remember, labeled data is considered as the output or the target of our data set, and to learn the relationship between the input features. Here we can say it's input features are also considered as the independent variables, or in normal mathematics they are taken as x, right? You remember the when you are computing like linear equation, you have f of x or y, which is equal to 2x time plus b, right? Something like that. And those input features and also known as and also known the output target for future prediction. The output target also you can say it is a dependent variable. As we know in our normal equation, where we were saying that f of x or y, that f of x or y, it is called target. And always in mathematics, we compute the mathematical equation by finding the value of our function, and our function is characterized or is labeled by y, right? That's why is what we call a target variable in the context of machine learning or artificial intelligence. Right? I hope everyone now is ready to demonstrate or describe what is a supervised learning algorithm? All right, it's when you study for the problem, and at that time you are having both input variables and output variables, right? So in supervised learning, you have to deal with these two technical terms or these two algorithms. One, it's a classification, another is regulation, right? And in classification, what do we deal with? And in regulation, what do we deal with, right? In classification, sorry, both classification and regulation are the supervised learning techniques. This is what you have to know. This is what you have to keep in your mind. They are both supervised learning. In the next class, we will learn another technique of machine learning, which is called unsupervised learning, and also reinforcement learning. And uh, deep learning algorithms. But let's now talk about the the supervised learning, right? Also, they use labeled data. You know, the purpose here we are finding the y, the value of our y in our normal mathematical functions, right? That is called considered, or it's called labeled data to train a model, right? We are having both input features and output feature, and all are used to train our model. And what is the purpose of the model? Is to help the machine learning engineer, to help the business analyst, to help the government institution, to help the NGOs, to help any to make or to take the future decisions, right? I hope you understand now. Then, but they differ in the type of the output to predict. You see now, we are talking about classification and the regression. Both they have the input feature, but they are different. What makes the difference between them? It's about their output, their target, their label. Few qualification here. In classification, the label is this categorical or discrete feature, right? While in regulation, the label is continuous. It's a numerical. You know, in regulation, the output is numbers. It's a numerical, which is continuous. That can be changed at a certain time, right? While in classification, the outputs are discrete. It's a categorical, right? Okay, we see some of examples. Now, let's see one by one. Classification, predict categorical or discrete outcome, right? It means here we are predicting our y. Our variable y is categorical, or we can say it is a discrete. Then meaning the result belongs to a specific class or category. It means that you are predicting a certain input is if it belong in a certain class or category, right? For example, you want to check or you want to predict if the students will pass the exam or no, right? It means that at that time your input is the marks of the students, attendance of the students, and others. But that's the most important features that will help the machine learning engineer to train a model that will predict if the students will pass the exam or not pass or will fail, right? Then here we have also assign input data to predefined label, for example, yes or no, this is the y. Our y contains only two values, sorry. Yes and no. We have another target, which is pass or fail, as I've said earlier, for the student performance. And you are detecting if this email is spam or not. Our target is spam or not spam. And also we are detecting the patient if has disease or not. This is some some of the examples of our why, our target, our label, right? And this is the target for classification. Remember in the early definition, they are both, even if they are classification, they are in. Okay, even if both they are supervised learning algorithm, but their difference is about the label. You see, for classification, the label is categories. We see how is it for regression. Okay, let's see sample of classification here. We are dealing with the student if is eligible to sit for exam or not eligible. As you know, you are a student currently, and you know your eligibility to sit for exam now. We consider for the attendance of the students if is greater than or equal to 80%, and we consider the performance in the formative assessment if they are greater than or equal to 70. At that time, a student is allowed to sit for a exam. That's two variables I'm mentioning that we are applying on now. It's called the independents, the inputs, right? The predictors, the variables, right? But for our data set, we are having attendance and we are having assessment assignment completed and the average score, right? Here you see the student who is eligible for this dataset we have, once we check both attendance and assignment completed, and this guy has the average score which is greater than a 70, which is a 78, and he's eligible to sit for exam. But this guy and this guy, they are not eligible to sit for the exam. And once we analyze this data set, you see that all or each student with the marks greater than or equal to 70 is allowed to sit for the exam. Right? This is the analysis, and the analysis is made manually. I make it by using my domain knowledge, and I'm no longer, or the company or the institution, our institution no longer need to make this decision manually, right? We need to train a model where we will enter these records, and if the model analyze that the students average score or attendance or the formative assessment is greater than the certain threshold or condition, and we consider that student as eligible to sit for exam, or the model will decide that the student is not allowed to sit for exam once a certain condition is met. Small thing to clarify here. There is no condition that we make in the way we are training a model. We don't need to set any condition because we run from the past experience, and you will not train your machine learning model even if you don't have a past examples. And that's the one condition that you must know. We train a model while we are having the past data. Okay. Okay, let's proceed now. You see from this dataset, our label or our target, because it's a classification, our target is this one, eligible for exam. It's our target with only two values, yes or no. Okay, and at that time you see it's a categorical, it's not continuous, it's not a number. And common algorithm that are applied for the classification problem. This is some of the algorithm that are applied, and we cover every algorithm we mentioned here. We'll cover, and I will recommend you another other algorithm that are classified as classification. You see, first we have logistic, regression, and naive. One thing I have to mention here, you remember logistic regression and the naive bias, they are only applied for classification, and they can't solve the regulation problems, right? They are uniquely used here in classification, right? Alas, decision tree, random forest, SVM, KNN, and those remaining algorithms, they can both work, or they can support both classification and regression. They can solve such kind of problems. Okay. Now let's see another example. Given a student with marks greater than 80 and attendance is 8, assignment done, the model will predict, yeah? Yes. And we don't decide this manually. Take this as unseen data for our model. What is unseen data? Are those data that comes in testing. And you remember when we are training our model, we have two parts: training part and testing part. And we are seeing this as unseen or new data. New data are those data that are considered as unseen. And you, after training your model, you feed a new data, and your model predicts what is the outcome. From analyzing the previous data set we have, we see this guy with the guy who are eligible for exam. This guy has 18, this is 70, and this is 10. As you see, the guy whose completed assessment is greater than or equal to 70 is allowed to sit for exam. That's why here we are saying we are having new data where the attendance is greater than 85% and the assessment completed is 8 assignments, and you see the condition now is matching. That's why we predict that this new data is will be predicted as eligible to sit for exam. Okay? Now, I hope no one with the problem for classification. And if there is no problem, well, you can allow me to proceed with the regulation, right? Okay, right. I hope you understand. Um, for regulation, what's regulation? And as we have mentioned earlier, regulation is one of the supervised learning algorithms which runs with the problem that predicts the continuous the continuous values. For example, you are predicting the house price. What will be the price of your house? What will be the price of your parcel in the future? Right? And to predict that, you need to run from also from the past data, from the past experience. Other things. Okay. Now, by definition, regulation predicts continuous or numeric outcomes. It means that you are having both input and output variables or filters. Then meaning the result is real number. The output that we are expecting to get, it's a real number. Here, you see, things changed, right? It's not category now. It's a real value. It's continuous value. Predicting the temperature for tomorrow, predicting the humidity of tomorrow, predicting the rainfall about tomorrow, predicting the predicting what? Your income in the future, right? Something like that. And the meaning, the result is real number rather than a category. Okay, understandable. The goal of this model or this kind of algorithm is to estimate the quantity or value based on the input feature. We deal with the quantity, not quality, right? Quality is we mention or we deal with the quality in the other algorithms. And now, let's see this kind of data set, student final score prediction. You know, you are a student, you are learning, and you want to know according to the hours I've studied, the hours I make my self studies, my according to my attendance, and according to my formative assessment. Uh, I want to know what will be, right? What will be my result after doing my exam? You know, this is some of the characteristics you need to consider. First, it's your learning hours, the hours you have attended in a class, or the hours you have done with your self studies and your attendance, okay, and your formative assessment you have completed, and okay, and the marks also, the marks you obtained in the formative assessment, and after that you can build a model that will predict what will be your final score during the exam, right? Okay, you see, let's analyze this guy, this data set. 48765 is predicting, our model is predicting, or our data set is predicting 65.4. Now it's 690. You see, once we analyze, let's analyze this. If this guy completed six as nine assignments, learning hours is 6, and attendance is a 90. You see, his final score is 82. There's one who fails. His study hours is 2, assignments 4, and attendance is 60. You see, probably this guy will fail even in normal life. Even if you don't attend the class, you don't make assignments, you don't exercise more, it means that your result will be pure, as we see in this data set. Okay. For another low, 8, 95, 10. This guy, you see, he's obtaining larger marks among the others. And this is in the moderate, okay? It's 3 hours, 17. Yeah, 70. Yeah, this is the max for this guy. You know, your study hours, it's moderate. It seems like it's a moderate. It's in the middle. That's why he is obtaining 55.6. What you have to know here, this is a regulation problem because the output is the numbers. It's numeric, it's continuous. You see, no one with the same output with the other one, right? Even if they may have the same output, the, it's possible to have those guys, they are having different input, right? Okay. I hope you understand now what is regulation, right? And so this is a summary of what we have covered in the last classes. Okay, this our target label, it's a final score which is in continuous numeric value, and we have the common algorithms that can be applied to this kind of the problem. We have linear regression. One thing I have to mention about this linear regression, this is unique algorithm that works for regression problem. And in linear regression, you need to read your note, your class handouts. You need to go to your e-learning and see what you have uploaded there. Here we are having linear regression, polynomial regression, and so on and so on. You will need more from your learning materials, and you have decision tree. This decision tree regressor, random forest regressor, support vector machine regressor, gradient boosting regressor. You see, for every program, this decision tree we have it in also classification, but the difference is this one. Here we say decision tree regressor, but in classification it's a decision tree classifier. And while you are importing from sklearn dot symbol dot what and what, you will import decision tree regress classifier for classification, and you will import the decision tree regressor for regression problem, right? The same for random forest, SVM, and gradient boosting algorithms. In this gradient boosting algorithms, we found the difference or several algorithms where you can find XGBoost, cut boost, right, GBM, and so on. You need to do more exercise in order to be familiar with the kind of the AI projects, right? Okay, another example here. This is for testing. We have our model is receiving new inputs, where we are having a student with study hours which is 7, attendance 90, and assignment completed is 80. Then what our model will predict? Probably our model will predict 85.3. This is not the exact value because this can change. Depends on the performance of our model. If our model accuracy is lower, it will be complex to predict this value. But once our model is accurate, is not finding any underfitting or overfitting, probably we predict this certain value. But also we have to see here, it's a closer, not the exact one, right? And remember, in the machine learning algorithm, we try to minimize to reduce the noise or errors. We can't eliminate the errors. If anyone told you that I have eliminated all errors from my machine learning model, uh, pay attention for that guy. In machine learning, we try to minimize. Even as a human being, we do not eliminate the errors. In normal life, no guy can eliminate the error from a certain field. We try to minimize. And we try to make a model that works like how human beings work. Okay? Okay. Now let's see summary. Classification and regression for the output. This is category, label or class, continuous real numbers or real values. About the targets, example of targets. This is eligible according to the set we have mentioned earlier, and this is for final exam score. This will be the numbers, and the goal is to assign the categories to the variables, to the input variables. And here we predict the numeric values, which is continuous somehow. Then the evaluation metrics. In evaluation metrics for classification, we deal with accuracy, precision, recall, F1 score, confusion matrix, and area in the curve. Okay, those are kind of the metrics that we apply for classification problem. While for regression problem, we apply the metrics which is mean absolute error, mean squared error, root mean squared error, and R square. Okay, you see they are also differ for the metrics, right? I hope if you have the problem and you know how the category of your problem, you will also know which metrics I will apply to this kind of problem. Okay? I hope this is very easier. Easier? Okay, easier. So for the algorithms, I've mentioned this logistic regression, random forest classifier, and so on. Here we can apply linear regression, random forest regressor, etc. Okay, the algorithms are many and are many. Can also apply ANN. You can also build your own algorithms without dealing with this algorithm which was well implemented by the researchers. You, as a machine learning engineer, you can build your own algorithm. Why not? This is possible. Okay, here we have key takeaway. For use classification for predicting label or categories or classes. But while for regulation, you can use it for predicting numerical value or continuous values. Okay, that was quick recap. Okay, let's solve one of the problem using this classification. Um, I will try to do this. Okay, we have a scenario here as a student exam eligibility system. Here in the university or college, every student must meet a certain condition to be eligible to sit for final examination. The academic board monitor the attendance, assignment submission depends on the college. For us in our college, we monitor the attendance of the students and the performance of students in the formative and continuous assessment, right? And you know the condition you consider, it's not no matter to mention it here, every one of you knows. Okay, and for our scenario, we consider also about the discipline performance throughout the semester. Okay, the goal of this dataset is to determine whether a student is eligible to sit for exam based on the key features or attributes such as attendance, assignment completed, disciplinary record, and average score. These are the our input features. In attendance, we measure the class participation. Students with the attendance below 75 are considered to be ineligible. In our dataset, once your attendance is below 75, you will not be allowed to sit for exam, right? This is the case or scenario for our data set. And according depends on the institution. The institution has their guardian to sit for exam, okay? And now assignment completed. Number of submitted assignments during the term or semester, the minimum of 6 assignments is required. It means that if you have submitted the assignment which is less than 6, you will not be eligible to sit for exam. And disciplinary code indicates whether student has any recorded misconduct. Uh, if you are you your conduct is not perfect or decent, okay? Uh, for example, you do a certain illegal things in the college or in the university, and okay, at that time you will not be allowed to sit for exam. And this in this record, we record yes or no. This is not our target. We are having yes or no, but it's not our target. Our target will be mentioned later. Okay, the average of the continuous assessment marks. Okay, using these features, we label each student as either, you see, 1, 2, 3, 4. These are the input features. But what about the output features is the students is allowed to sit for exam. In that feature, we are having only two values, yes or no. Yes is eligible to sit for exam, not is not eligible to sit for exam. This data set can be used to train a classification model. For example, this and this, random forest and so on we have mentioned, to predict eligibility to test pre-processing methods. You know, like when you are dealing with this kind of the problems like machine learning problem, try to spend at least 60% of your time dealing with pre-processing, where you deal with missing values, outliers, noise, and feature engineering. It's many. You need to spend a lot of your time in this kind of stage. Once your data set is processed well, you will get the best accuracy. Okay? Okay. Um, okay. Make sure your data set is well pre-processed before you move on to model selection and model training. Okay? Then after that, we evaluate the performance metrics such as accuracy, confusion matrix, classification report, and so on to see how our model is performing. Okay, now let's start. The first stage, as you know, we need to do what? To load what? To load libraries, to import libraries. The library we need now, we need pandas as PD. What is the purpose of this PD? This is taken as an alias, and this is the library name. And you know the pandas purpose is to manipulate dataset and the analysis. Its purpose is for manipulation and the data analysis. That's purpose of pandas. NumPy deals with numbers arrays. And more sklearn, you know this is a library from scikit-learn which helps to deal with the preprocessing techniques for evaluation metrics for also model selection and so on. Okay. And here we have label encoding and the standard scaler. What purpose of label encoder? This is there and help us to transform our data from categories to numbers. And you know we can't train a machine learning model or with categories. Depends on the algorithm. We have seen that in decision tree, it is possible to train a machine learning model with categories and with the missing value, but not commonly to other model to other algorithms. In the other algorithms, we need to convert our categories into numbers in order to make them run. Okay, then we implement those uh, techniques by using label encoder. You can also use one hot encoder, or you can use ordinal encoding, and so many encoding techniques. And we have also standard scaler. This helps us to scale our data in order to prevent our model from being linkage, from data linkage problem. And you know the problem of data leakage. I hope you remember. If you remember, type in the comments below. And then and we are having here random forest classifier. We are importing this from ensemble, and you know random forest. Why is it ensemble? Because it's a collection of multiple decision trees, and in a decision tree, it's a single decision tree. Okay, because our problem is a classification. That's why we import random forest classifier. Once it is regression, we can say random forest regressor like this. But there is no need for regressor because we are not working for regression problem. We are working for classification problem. Let's keep it as it is. Random forest classifier. And this is one of the algorithm or model we are going to train. And this is a logistic regression. Remember logistic regression, how it works in the probability from 0 and 1. And also it works, it's best suitable for classification, and it is best suit it works for binary classification and multi-classification, but best suited for binary classification. I hope you remember this, okay? And we are having metrics from sklearn.metrics. Depends on the metric you are going to apply. Every metrics is imported from this package or this library. Import accuracy score. You know, this is a matrix for regression. Import classification reports. Import confusion matrix or confusion matrix display. This will plot it and make it easier for interpretable. Okay. And we are having this library matplotlib for data visualization. Okay, once you know you want to visualize on your data on the plot, you will use these two libraries, matplotlib and Seaborn. Okay, and this is the line to import our dataset. How our dataset is looking like. Let me open my dataset here. It's here, classification, and our dataset it is this one. It is in a CSV format. You see, we are having student ID, student name, attendance, assignment, submitted, disciplinary, average score, and the exam. And this exam is our target. The remaining one is the input variables. And all the input variables are not needed to be fed to our model. You know, this ID and this nothing will pray to our model. There is no needed, and we need to drop them. No, do not drop them directly from your dataset. You need to drop them using the Python scripts. Okay, let's close this dataset. We have seen this. Okay, coming back here, we load this from df data frame is equal to pd, these pandas that used for data manipulation and the analysis. Then read CSV. We are reading our CSV dataset. Depends on this will be changed depends on the type of your dataset. Okay, I've mentioned in the previous classes. Then df.head, what is the purpose of this? This is there to display only first 5 records from your data frame. As you see, it is 5 records. I can change it like this. If I want like 100 record, I can change like that. And you see, we are seeing the 100 records, okay? And no need for 100. Let me keep like 5. This is first 5 record. How about last 5 record? For last 5 record, it's a df dot tail. It's okay. You see, we are seeing 199 record, which means that in our data set you are having 200 records from 0 up to 199. Okay. If we want to see like last 10 record, you change the value there and you see the last 5 records there. And here you can interpret your data set. This is the features we have: student ID, name, attendance, assignments, disciplinary, average score, and eligibility for exam. This is our target. I hope you remember this is our target. It's our label. It's the output. Okay. Now let's proceed. Once you proceed, you see step number 1, not step number 1, this is like step number 2. We need to check the missing values or checking the dataset info. Our dataset info are checked by using df.info method. This info method displays these values from here up to here. Okay. As you see, we are having 200 records and the entry is from 0 up to 199. And here we are having field number 1 or feature number 1, student ID has or 200 records, and its data type is an integer. Name 200 records, its data type is an object. Once it's an object, it's a string, you know. And attendance 200, integer, assignment 200, 200, 200, and in eligible 200, and it is object, and this one is the object. And these 3 features, they are there and they need to be converted into numbers. And also, you know, we drop the one which is which is not needed or which to our model. Okay. Now you see the missing values. To check the missing value, we check them by using this line df.isNar or isNA. You can say isNar like this. They are all used to check the missing values. Once we run, you see the value remains the same. You can say isNar not applicable or isNar dot sum. At that time, it will print each feature with the missing values. You see, all of our features, they have missing values of 0. Let's imagine we are finding the missing value from our dataset. How will we handle the missing value problems? First, we have to think about these 3 imputation methods. Not limited to this, you can think also you can handle missing values using constants or using your domain knowledge, okay, or using other methods. But now let me talk about these 3 imputation methods. First, when dataset contain missing values, we can handle by using imputation, replacing missing entry with the estimated values. The 3 common method imputation methods are mean, median, and mode. Each is suited for different data. We apply each techniques for different purpose of different data. Start by mean. Simply, mean works when your dataset has less or hasn't any outlier, and it works only for numeric values. It replaces missing value with mean average with the available data when it used suited for numerical data, for example, mark height and income. Works best when data is normally distributed and there is no large outliers, even if there is no outliers. But for data with the large outlier or with the outliers, we need to replace those missing values with another method which is called median. Okay, this is a sample of dataset features where we can apply mean. We can apply mean for this non-value and mass score. Here in student, we can't apply mean. Here we apply what we call mode. We'll see how mode works. Okay, then mean, you know, mathematically mean it's a total sample over total. Total sum of is the sum of your samples over total samples. And here you see this C will be imputed or replaced by 80. Okay, Now, this is the Python code to implement to impress missing value is mean. You say df mass score. This is our feature data frame feature. Dot fill not applicable bracket df our data frame math score because we don't. It's a feature that we are going to replace them missing value with mean and dot mean function and in place is equal to true. Why we say in place is equal to true? We say in place is equal to true to prevent to create a new data frame, but here it will go in our data set or in our data frame and replace the none record with the mean. Once we don't put this in place, it will create a new data frame. Remember to put this in place as equal to true. I hope you understand the purpose of in place is equal to true. Okay, that's it for mean. How about median? It's the same with the mean. Both they work with the numerical values, but this work or it's best suitable for skewed data or data with extreme outliers, the data with the features with outliers. Once you have outliers in your model, or sorry, in your data set feature, remember to think about the median, and you know how to detect the outliers. We see how to detect outlier in the next slides, in the next cells, sorry. This is the example where you can apply median. You see 505, 10,000. Do you see? Different from 520 to 10,000. Here, as you see, and as you judge with your eyes, there are outliers, there are larger difference between those numbers. That's why here you need to think about the median. And we do not visualize this manually. You need to apply like z-score or interquartile range to determine or to check if you have outliers in your dataset. Right? Okay, right. Then for that, we can see how to implement it in Python code. And we say df salary, it's our feature name, dot firina df salary dot median, then it press true. In press true also we are re-updating the values here with the median of the whole samples or records we have in that feature. For example, if you have like a thousand values, this technique or median will compute the median of 1,000 values and will replace the value obtained in this non-record. Okay, okay, that's true. And how about mode? This mode is a little different from the mean and median. This works only for categorical or discrete features. If your feature contains the categories and you are having missing value there, you need to think about the mode. Mode, which is the most frequently recorded or items. I'm going to use Kinyarwanda. Okay, I'm sorry. Um, uh, for example, here in gender we are dealing with categories and we are having one missing value, and we need to handle this missing value by the technique which is called the mode. And the mode, it is working for the dominant records. Okay, uh, the one which comes most frequently than others. Okay, let's count it manually. Gender one, sorry, male one, male two, female one, which means that our B9 value will be male because we have two male and one female. It's okay. Logical behind you get it, right? Okay, as you see, mod it is used for, or we replace the non-values with most frequent value. Then the most frequent value is male, which means that B, the student B will for the non-value will be replaced by male. Okay, I hope there's no problem about this imputation. How to implement it in Python? Df your data frame, current data frame, dot fill now df, sorry, gender, then dot mod and 0, and in press true. What does it mean 0? In this 0, the meaning of 0, get most frequent value in the column. In that feature you are working on, we are saying 0, which is we need the most frequent value. And you remember in the last class, I have said that 0 depends on the law or the record, and 1 depends on and 1 means column. It's okay. That's why here we put 0. 0 means we are dealing with the records. We are dealing with the values. It's okay. And this is in press true. What does it mean? It updates the data frame directly without creating new one. I've mentioned this early. Once I give you the certain question of this, what is the meaning of in press true? I hope every one of you will answer this. Okay. Easier. Easier. Okay, let's go. Let me delete this. And we are going to detect the outliers. And above imputation method, we were talking about the outliers. And how to know that you are having outliers. You need to use first interquartile range or z-score. I know you know the mathematical behind we have discussed about in the class. And if you have the question, you will ask. Okay, we give you a time to ask and respond in the normal class. Okay. Then how does actually work? Interquartile range. This is there to detect the outlier, and it works for only and remember the mean and median, they are working for numerical values, and this actually works for numerical values, not for the categoricals. And we need to say number of columns, a new variable, which is equal to our data frame we are working on. Then select data type, include np numpy dot number. We are saying that numpy will work for the numbers and arrays. It means that we are taking only numbers, the features with the numbers or with with their type is numbers from our data set, and from our dataset feature. That's why we mentioned columns. Okay. Then df number of columns is equal to df number of column dot apply lambda x, which is equal to x firna. Then x is equal to dot median. Okay. Here we are taking in non-values and we put the median. Okay, and after putting the median, we are going to detect the quantile range. What does it mean? Q1, this quantile 1 or percentile 1, or 25, or sorry, it's a quantile 1 and it is 25 percentile. Q3, it is 75 percentile and it is a quantile 3. Okay, and the Q2, it is at 50 percentile. Okay, I hope you know this mathematically. And Q1, how is it equal? It is equal to df number of columns, those numeric features, dot quantile 25. This is a method which is there. Take this as like this and this as like this, and it will know, our Python will know how to compute it mathematically. And Q3, it is equal to df number of column dot quantile 75. Then our purpose is to compute IQL. IQL is equal to Q3 minus Q1, which is this one. Then we need to set the lower bound in order to know in order to know if we are having outlier, and the upper bound in order to know the value beyond the upper bound and the value below the lower bound. They are considered as the outliers. Okay. Sorry. Then the lower bound is equal to Q1 minus 1.5. This is a formula times IQL, the value obtained from this value, this formula. Then upper bound is equal to Q3, this one, plus 1.5 times IQL. Everything is there and it's clear. Okay. Then you are going to detect the outliers. The outliers, we need to define a new variable, and it is df, number of column. Those column we mentioned there. Once it is less than lower bound, the value lower than or less than lower bound, it is now this formula is concluding that it is an outlier, or this is OR gate. The df columns greater than upper bound, and the value below the upper bound, which is greater than upper bound, those values that are not in the range. What range we are talking about? The range which is considered as not outliers is the range from lower bound greater than or equal to lower bound and less than or equal to the upper bound. Those are taken as not outliers, right? Then the value that are outside the range, they are considered as the outliers. I hope you understand. Okay. Then we need to count the outliers we have. It's this outlier mask, because this is talking about the outliers, and dot sum. This will compute how many outliers are we having in each column. Okay, and this is the way to display and show the laws contain the outliers in data frame. We have to say the df outliers mask dot any. If we have any laws, any feature with the outliers, we take it and display as a law. And we are saying len this function measure the length of measure and display the length of our data set. Yeah, our data set or our data frame, the length. Okay, and we display. This is the function you are calling display, and this, yeah, this is a function to display. Okay, as you see, we are detecting the zero outliers, which means that in our data set there is no outliers. If you have any, they will be listed here, and the number of rows containing at least one outlier, there is zero also. And you see our data frame, it is empty. We are displaying only headers. Okay, I hope you understand. So for example, suppose you are having, sorry, let's see how we can check the outliers using box plot. We are checking outliers using interquartile range, z-score. Also, there's another technique which is called box plot, where we plot the values, our features, and once we have outliers, we'll see. And remember, in our data set, there is no outliers. These are the codes to detect the outliers, okay? And to report all field we have. And if we are having outlier, we see something like a ball here. I hope you remember. Ball here or here. If you found that we have outlier, you will see the ball. If you don't see a ball, it means that your data set is clear. It's okay. After that, Um, this is to display our data frame. Okay. Now, now, if you found the outlier, you will see how to remove it. Check the codes that we have in the code base while we were working on the physical class, and see which code to remove the outlier. But there's nothing more. What you have to do is to change something here. You change this, you put instead of or, you put and instead of less than, you put greater than or equal, and instead of greater than, you put less than or equal, and this condition removes the outlier. But check it well from a normal notebook, a normal physical notebook, not this one for video recording. Okay. Now handle categorical columns. Remember, in order to have our machine learning algorithm or model being trained, we need to convert numerical categorical values into numerical values. We have this one, which is disciplinary code and eligible for exam as categories. Why? Because this one is a category and this one is category. Why I can't say, why I didn't say mention about this? I didn't, but it didn't mention about this because I don't need this one and I don't need to convert this into numerical. I will drop this later, okay? But we are going to convert this one and this one. In converting that features into numerical, we need to think about we are having like three or more techniques. One, it is in label encoding, one hot encoding. Second one, it is one hot encoding. Another one is ordinal encoding. I'm sorry. Three, it is ordinal encoding. Another one is target echo. Fourth, it's a target encoding. Okay, let's see some summary about these encodings. Label encoding is when you transform your data, you are having like uh, two or three values or five, depends. In the target, once you are having five, you can use five record. I recommend you to use label encoding. Sorry, in the target feature, once you are having like five values, there is no need to convert target feature using one hot encoding. You can convert it using label encoding or ordinal encoding. Well, label encoding, it takes one value and it assign the auto number, and you can check which number is assigned to my values by checking the original value with the encoded values. And ordinal encoding is to take the values that you have in your feature and you map it. You take the categories you have in your feature and you map it to the values according to your need. Okay. And what one hot encoding, you remember how one hot encoding, this one hot encoding, it takes the value from a certain feature and it creates the new features from those values. For example, we are converting like gender as using one hot encoding. It will create, we have first of all original feature, which is gender, and we are creating new features, which is male and female. And there is no record will be a male at a certain time will be a female. First it becomes a male, and for female it becomes zero, right? And for the next record, if it's a female, she's not being also a male. You remember how I will explain this, okay? And target coding, we see. Okay, let me delete this because it may cause the errors. You need to exercise how all both encoding works. Okay, how about this? Yeah. And to implement label encoding, because we are having values yes and no, let's transform it using label encoding. You mention your DF, our original DF data frame we are having, and passing this feature, the column name we are going to encode, and label encoder, which is this one. This is the initialization of label encoder, and we take it here. Then we say fit transform, then df disciplinary. We, pa- we pass it like what this line means. This line is going to do what? To take the values because we are having yes or no, is going to take 0 and 1 and assign it to yes or no and update our field. We are updating our field because we are having this data frame with this feature as the same as the one we have there in our data frame. If we want to create a new field, to have it as new field, we can say here like data frame 1. Sorry, disciplinary 1. Once I say 1, you see, let me run or. Yeah, you see, the original disciplinary record is containing our categorical features, and the new one created is containing the numerical features. You see, for no, it is transformed as 0, no, there is 0. While yes, it is transformed as 1. This what I have implemented here. This is called feature engineering. In feature engineering, remember we have create, modify new variables. We have to create new variables or we have to modify the old variables. But for my feature engineering in this case, let me decide to modify the one I have. I modify the values. It's okay. I hope you see you have obtained how to create new variables. Once I implement, you see I have modified here, and to have the changes here, I need to run or. Once I run or, you see my variable is changed, the values is updated, but the feature remains as it was. The same for eligible. Let me put 1 here and run or to see the change. Okay, as you see, our target now it is yes and no, the old one, but the new one we are having 1. 1 it is assigned to yes. It means that in our cleaned data set where you are having 1, our model will understand that it is yes. He's eligible to sit for exam. It's okay? I hope you get the logic behind, right? Then for 0 it is no. And here I'm done with feature engineering, but I don't need to create a new feature. I need to update the old one. That's why I need to delete 1 here and run or. If I run or, you see the exam the eligible for exam is updated. 1 means yes, 0 means no. Okay, that's it for categorical encoding using Rebo encoder. If you want, you can use one hot encoding, you can use ordinal encoding. Okay, now let's go to feature scaling. In feature scaling, I need to first to display the column I have. This is not feature scaling, it's a feature splitting. Feature splitting. Okay. I need, for example, first of all, I plotted or I displayed my column to see the column name you have in your data set. You mentioned the data frame you are working on, dot columns. At this time, you are displaying all columns you have. And in this column, how many columns do I need as my input, independent? Yeah. And how many columns do I need as the dependent or target or label or class, right? For this case, student ID and name, they are not needed in our input. Our input is represented by X. Even because they are not needed, we need to drop them. We need to say df.drop, and we make the list like this, and we drop first of all student ID, which is this one, and we drop name because we don't need those features in our input. Okay. And in the input, remember we need to exclude our target. Our target is eligible for exam. That's why I dropped also from the X. And I mentioned axis is equal to 1, which means that I'm dropping the columns, not the rows. It's okay? Then I need also the target. Remember our function f of x or our y is equal to ax plus b. Okay, which means that in this time we are having x and we need to have y. Our y is equal to df eligible. Eligible is our target. It's okay. Let me delete this formula. Okay. Now it is understandable. Once it is understandable, we are ready to split our data set. First of all, you need to run to check if your code is running. If it is running, you see we are having this green green V, and we are coming from the feature splitting, and we are moving to train or dataset splitting. Train test split. Train test split. Remember, we were having array the x and y. In x and y, we are going to divide both to divide them into train and test. That's why we define x train, x test, y train, y test. This x train and y train, those are the variables or the features or the records that we are going to train. The remaining x test and x y test, they are there for unseen data. They will be used to evaluate our model performance to see if our model has generalized well, has converged, hasn't overfitted or underfitted. It's okay. Then from test train split, we have imported this array from the importing package that we have started on. Then we put x and y. Then test size is 20%, 0.2 it is 20%, which means that the remaining 80% are going to be used for training. And random states is there to stabilize our accuracy or our score. Then if you think you have your data set is imbalanced, you can add another variable which is called stratify, and stratify is equal to y. This will help you to do what? To balance your data set. If your data set also is imbalanced and this can't work perfectly, you may think about another method. One it's a smart and another it is class weight. You have to think about it, and you can apply to also to your data set in order to handle the class imbalancing problem. I know you will meet with such case of the problem, and you have to think about smart or class weight. Once you will think about those, once this is not working better. Okay. And we need to print the training set and the testing set by using xtrain.shape. This we print the size of the record we are going to train and the number of features we are going to train. The same with this one, the number of record we are going to test and the number of record we are going to train. As you see, we didn't drop any record from our dataset because there was no missing value, there was no outliers. Okay, what we have dropped is a feature, and once we drop a feature, it will not those dropping or those engineering techniques or those pre-processing techniques will not affect the size of the record we are having. Only we are removing the feature, but the number of record remains the same. Okay, it means that now we are going to train 160 records and four feature, and we are going to test 40, which this is 20% of 200 records, because once we add this and this is 200. To confirm it, we can say len df to see the length of our data frame. Okay, you see we are having 200 records. Or we can also say df dot shape. What is the difference of this? This count the total number of record, this len, but this shape count total number of records with the total number of features. You see now we are having 7 features. In 7 features, remember we have dropped student ID, student name, and our target. We removed 3 features. That's why in X train we are remaining with four features because the 3 are they dropped. And it means that in Y train, we are having only one feature, which is eligible for exam. Okay. Now, after dataset splitting, you can think about what will be happen if I meet with the data linkage problem. Before you meet with that problem, you need to handle. How to handle? You need also to transform your dataset. You transform X-train and X-test. For X-train, we are coming with a new variable, which is X-train transformed or scaled, which is equal to scalar. Where this scalar is coming from is from standard scalar. This is the initialization of our standard scalar. In standard scalar, we are having, I hope, z-score scalar and the minimax normalization or minimax scalar. Okay, now we are using standard scalar where our new trained data is equal to scalar dot fit transform. We fit transform for X train, and we use transform for X test for testing data. You have to keep this in your mind, and this will help you. Will help you to prevent from the problem of data leakage. We implement this before we train our model, and we can print their size, their values. You see, we fit data between the values of -1 and 1. That's it. That's why we are having 0, -1, and extra. These values, they are different from the original X values. Let's print X train value dot head, and we see how it looks. It looks different from the one scaled. You see, we are having as the original values, but for those which is scaled, they are scaled in the certain or the same range between -1 and 1. And this also helps to prevent from the problem of data linkage, and it allows the model to converge. Okay, to converge. Then the next step is for model training. The model training you have seen in classification, we have seen the algorithm that are applicable for classification. We have seen naive bias, we have seen logistic. Here, we can apply naive bias, but it's not recommended because naive bias it is recommended for string or text dataset. And our dataset it is not text. I can recommend you to use naive for spam email detection, okay, harmful messages like that, such kind of data set. Okay, and now because we are dealing with mixed numerical and the categories, we are using random forest classifier, and this was imported early in the starting set. So first we need to initialize our model, which is random forest classifier. Number of estimators is equal to 100, which means that our this algorithm is going to take the dataset and divide into 100 splits, and it will run from one split to second split, and it will compute the average accuracy, and it will plot the accuracy it will achieve. Okay, it will first check in one first sample. It take the dataset randomly and divide into different samples and run from one sample, second sample up to 100 sample, and to compute the average accuracy it found there, and to display the accuracy. And we said random step. Okay, here you can add another parameters. Once your model is producing the result which is not accurate, you can fine tune this model. Okay, then we need to train a model. This line is for model initialization. model initialization, and this one it is for model training, exactly. Okay, like this. Then this is when we are going to make prediction. To train model.fit, we pass xtrain scared because the reason why we make scared is to prevent the problem of data linkage. That's why we need to train this one. Okay? Xtrain scared and y train. Where this y train is coming from? This is coming from our data set. This one. Okay? This one, y train. Okay? Then after that, we need to make prediction for our model. How our model is predicting the unseen data. And the prediction occur or happens for unseen or testing data. That's why we define a variable which is called y_predict is equal to model, our trained model, this one, dot predict. We use predict because we are predicting the classes, the categories between 0 and 1. Remember, after converting our our target label from yes or no, the value becomes in a range of 0 and 1. That's why we are need to use this one. What if you are predicting the probabilities? Probability from 0 and 1, 0 point something, 0 point something up to 1. We not use here predict, we use predict proba. If we need the probability, can use here predict proba like this, and you learn. And once you learn, you will get an error because you need to add something like this, add marks. And once you learn it again, you will see our model is working better. And if we scroll down, 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 yeah, there's no need to move for the next. Let's um, let's proceed here. There's no need, we don't need probability. Uh, we we are needing the categories or classes. Okay. For classes, we pass X test scaled, the one we scaled. Then to measure the accuracy or the performance of our model, we need to define this variable equal to accuracy score. This is the matrix we have imported in the first cell. This one, accuracy score. This one, it's okay. And we pass. What are we going to pass there? We need to pass y test because y test contain unseen data. We didn't train the test. And y predict because y predict it is containing testing variables, which means that this is our actual output. Here we have the output, and here we have the input. Input which is there for testing, not for training. And after that, we compute the accuracy. You see, our accuracy is 1 which is equal to 100 because I multiply it with the 100. And the accuracy is measured also between 0 and 1. There are also the probabilities. And if you want to report, in your reporting, you will not report this one, you will report this percentage. That's why you need to multiply your accuracy with the 100, okay? For making your boss understand what you have implemented. But in code base, you know what you have achieved. But in reporting, don't report one. One means what? 100 accuracy. Okay. Then that's it for random forest. This is first algorithms. Let's see how logistic regression performs for this problem. And in logistic regression, we need to initialize our model the same like for random forest, but we don't need parameter for number of estimators here. We can also define this random state. But this random state also is not needed because we set it from dataset splitting here. Okay, and let's use default logistic regression, and the model we need to train it here where we train x train scaled and y train. Then y predict is equal to that we are going to predict our model. This is a variable that contains our model trained, and we pass X test, and also we compute the accuracy. The accuracy is containing Y test, our actual Y, and Y predict is this Y predict also contain the X testing, the unseen data, both are unseen data. And as once you print, you see the accuracy also it is 100. Here, both logistic regression and random forest they are achieving the same result. And you can also train other algorithms. If, for example, if the accuracy here is less, you can also compute other classification algorithm to check which one performs better among others. And the one which performs better is the one to be reported. Okay, here I need to see how our model is working for unseen data. First, I need to define a variable which is called new data frame, which is called 2PD data frame. It's a function that contains data in a tabular format. And we have to say actual Y. It's a actual result that we having, and the predicted one. In the predicted one, we pass Y predict, and Y predict is it contains the X test. Okay. Then here we have Y test as our actual testing data. Then we put values to have those values from there. Then we do what? We display, we compute this one, we set the index for readability, index like 1 to something like that. Then drop is equal to true. And we print the results in. There's no need to print this accuracy because we have it already. This is the accuracy, yeah, for logistic, I hope, because the final cell we run, then we plot our result in head. We can plot like first 15 record. Because we trained, we tested 40 records. In 40 records, we want only 15 records and to see. You see, in the data set, we are having 0 as the input, the prediction is 0. Or they are matching. As you see, this is what we call result analysis and interpretation. Everything is matching here, okay? Which means that our model is perfect, okay? Now we can also plot confusion matrix. Confusion matrix is there to help the machine learning engineer to interpret how many false positive, how many false negative, how many true positive, how many false true negative. Okay, you see, in the confusion matrix, before confusion matrix, let's see what is classification report. This classification report contains this matrix precision, recall, and F1 score. What does it mean? Once precision are in the recall and F1 score are higher, it means that the accuracy will be also higher. Once they are lower, the accuracy will be lower. Let's see, this is 100, 100, 100, and the average accuracy is 100. Okay? Then for confusion matrix, remember we have imported this confusion matrix display. We need it as annotated like this. Then from predictions, we pass Y test because it is our unseen data which is not trained, and Y predict. As you see, for each matrix, we are needing Y test and Y predict. You need to keep this in mind. For each matrix you are going to evaluate, put Y test and Y predict. This Y test, we get it from dataset splitting. Y predict, it is the one you calculated from the model.predict, and you pass X test scaled or X test, depends on your variable naming. Okay, let's interpret. This is the result of our confusion matrix. Here, 0, 0, this is true, true negative. 0 intersection 2, 0, it is here. We have true negative. Our model to predict the true values are 35, which is true negative, which is better. And 0, this is this side it is for true label. It is the one we have as input. Then this is for the one we have as output, it's predicted label. Then let's see 0, 0 and 1. This is plus positive. It is positive because the predicted one is positive, where the input or the actual was in a negative, right? That's why we decided according to this one. It's a plus positive. Then how about 1 and 0? The input was positive, but the output was negative, which means that this is first negative. Then this is 1 and 1. The input is 1, the output is 1, which means that 1 compared to 1 it is true, which means that it is true positive. The true positive is 5, the true negative is 5. And once I give you the matrix like this, confusion matrix like this, and I ask you how many true positive, how many true negative, how many false positive, how many false negative, you will know how to compute them from this confusion matrix. Try to understand how confusion matrix works, okay? I hope this is not needed. Okay, for your purpose, if you want, if your boss asked you to clean the dataset and submit a cleaned dataset to him, you have to save a dataset cleaned like this. To save it is to say df dot to CSV, to Excel, to SQL, to any format you want, and you put the name of your dataset you want, and index is equal to 5. It means that there's no index that we have in the cleaned dataset. Let's see how this preprocessed dataset is looking like. It is this one processed. Okay, you see, we are having this one was having categories values, and this has categories values, but for the cleaned one, you see, we are having the one with numericals. But why this remain here? Because this was not dropped from a data frame, they was dropped from X. Once they was dropped from data frame, it means that in this data set, they will not be appear. I hope you get it, okay? Okay, that's it for classification. Once I got time, I'll prepare another video for regression. But the flow is the same. The difference, the preprocessing techniques, they are the same. The difference is from here for model training. For regression, preprocessing, they are the same. You need to handle the missing values, the outliers, what and what. The array or the array stage are similar, but the difference is from here. Here is where you use linear regression, and if you choose to use random forest, you use random forest regressor, decision tree regressor. Difference it becomes here, and becomes for the matrix. Matrix, as you have seen, it's R square, MAE, MCE, RMCE. Now, I hope you capture general understanding about this kind of machine learning. Okay? Okay, take your time to make more exercise. Goodbye. See you. Okay.